Swayam Prabha. Digital India. Educated India.
Hello and welcome back to the basics of working drawings. In today's module, we will look at the details and the other layouts which are to be given along with all the modules which we had covered, all the drawings which we had discussed in the previous modules. So this module will essentially be the last module which talks about all the detailed drawings which are in addition to what we have discussed till now. So looking at the detailed plans, so when we do a particular design for a particular house, say for in this case we do see that there is a small house which is there at the ground level. You have different rooms which are there, including a gym as well as a storage. So this is a typical layout which is there being provided for a particular case, right? So in this case, in addition to the structured floor, in addition to what we will be developing as a complete construction of that particular house or that particular building, in addition to that there are certain things, certain services, certain utilities which will be added upon on top of that, right? So in that case, these are nothing but in addition to the structural floor, these are structural floor plan sections and elevation. There are other drawings which are essentially the electrical plan and the plumbing layout plan, right? So the electrical plan gives you all the information about what kind of appliances are being attached there, what kind of appliances will be used there in that particular area as per the client requirement. In addition to that, what kind of fixtures and fittings which will be put in there in that household, what kind of lighting layout or what kind of lighting fixtures are to be utilized, what kind of air circulation appliances will be used, whether there is a AC. So if there is a AC, where will be the outdoor unit located, where will be the indoor unit located. So all of these things are being specified and are being given with the location and the electrical connections, where how they will be distributed along that particular area in which of the rooms, right? So all of these wirings are also to be connected to certain switchboards. So how will a layout work? For example, sometimes in case of a bedroom, you also require double switches, meaning that there will be one switch which will be switchboard which will be right next to the entrance of that particular room, that particular bedroom. Also on the bedside, you will have additional buttons which will do the same operation of turning on or switching off the lights or the fan which is there inside that particular room, right? So these kind of additional fixtures, they also require this kind of information to be provided for the people who will be executing this particular plan, right? So these drawings are nothing but a detailed technical representation of all the electrical and plumbing points which are there in the building which is being constructed or the floor which is being constructed, right? So this is an example of how a complete electrical layout drawing would look like, right? So you will have several different lines which are there, several different fixtures which are being represented. Along with that, you have to mention the dimensions of how the lights are placed, how distant the lights are with each other, right? Where will be the sockets which will be placed where, how many number of buttons are there on the socket on that particular switchboard to turn on or to turn on the appliances or the socket which is present there, right? Electrical socket. So all of these things are being described and specified in this particular document along with a different specifications sheet. So usually what happens is, along with this, sometimes clients also demand for a specific make type, meaning they'll specify a brand that we want. Say for example, a client specifies that okay, we want a switchboard coming from this particular brand and we want only that in all of our rooms, right? So in that case, as an architect, we need to go to the market, we need to collect or get our vendors onboarded with this, collect all the catalogs which are available for that particular brand, bring that catalog, discuss it with the client, finalize on a particular design, finalize on a particular layout or finalize on a particular make coming from that particular recommendation of the client, and then we can go forward with the finalization of this. Now this process is required to actually get the exact dimensions of the fittings which are there, which are provided by the particular manufacturer. Along with that, the sizes, the way it is to be laid out. In some cases there are sometimes certain precautions which are additionally asked by the maker, by the manufacturer. For example, a light fitting is to be placed at a particular distance from the closest wall. Sometimes the manufacturer also specifies that. So in that case, it is our architect's job or the person who is laying this out, maybe an interior designer, it's his job or her job to actually do this very cautiously and do this very accountably, right. So the accountability is a bigger case, because in both cases if the layout is faulty, if the layout is not correct, then in that case it may cause a hazard, right. For example, in electric layout, if the electric layout is wrong, it may create electric short circuits, or it may also create fire, right. If the plumbing layout is not correct, if the plumbing layout is faulty, then in that case the soil pipe may get clogged, the water supply may burst, and then there will be flooding in certain rooms. So these are some of the hazard points which are there, and that's essentially one of the other reasons why these layouts are also important, so that the design is safeguarded along with the utilities which are being provided in that particular case, right. So these are some of the important points, right. Moving forward, now in a electrical layout or electrical plan, what all things do we have? In certain cases, or often in certain offices, it is called as the electrical plan or electrical layout or wiring diagram, right, or is also called as the wiring diagram. So these are certain three common names which are generally popular in different architects' office. So either of them is actually the same thing. It's electrical appliance and electrical fixtures layout plan, right. In all of this, what do we have? This is a kind of a technical drawing that provides a complete visual representation of all the circuits and electrical systems which are being put in place in that particular building, which is under this particular development. Now in case of an electrical plan, what are the things that we can use it for, right. So electrical plans are used for, first and foremost, visualization of how a particular electrical system is of a building, of a floor, of a particular room, so and so forth, right. So all of that representation comes in at first layer, okay. So moving forward, next, as we discussed just on the last slide, safety and efficiency. So electrical plans are important to ensure smooth running of all the power systems which are provided in that particular layout, right. Smooth functioning of all the power systems which are provided in that particular layout. Next, you identify the risks. So beforehand, before doing the execution on site, before actually bringing the samples which are there, because actually procuring or collecting all the appliances which you want or all the fixtures that you want in the household, on the house. So in that particular case, you can actually identify the risks. Say for example, you wish to have a fan which is quite large in diameter, right. It's complete diameter, the length of its blades is quite long. So in that case, you do want, you feel like as a client, you feel like that yes, I want this, and you go and talk to the architect that yes, this is what I want to place in my house, or this is what I want to have in my living room. But as soon as the architect actually makes the circular layout of the area in which the blades will rotate and he places it in the room, then it shows that okay, there is a potential risk that it will hit one of the columns, or it will hit on the side, or it will hit the false ceiling layout which is there, because it's very big, right. So sometimes if clients are aspirational, these kind of layouts actually help us safeguard their own investments, which is quite a hard earned money, right. So that's very, very important. Moving forward, you know, as an architect, you will know the installation of how the tools or how a particular kind of electrical appliance or a system is being installed in that particular area, in that particular plan. Along with that, you will also know what kind of tools will be required for doing certain installations. Say for example, you are doing something, some sort of concealed plumbing, or you are doing some sort of concealed wiring inside a wall. right? So in that particular case, you will need a drill, you will need a chipper, you will need a cutting tool which will be cutting through the plaster lines, and then you will lay down the electrical layout from there. So all of these particular things, or all of these critical things, are to be done in that design, and that is how we get to know from the drawings, that immediately once you see the drawings, that this is the work is to be done in that site, in that particular site of question, then in that case you will already know how many tools you will be taking to that site, right? So this informs the electricians, this informs the people who are involved in the execution of that particular site, this informs the contractor as well as the client, that all of these things are to be done on the site for a efficient and effective installation of all the electrical appliances, right? Along with that, because as I mentioned in the last example, that if you are concealing all the wiring which is there, which is much more common in most of the housing or most of the residential layouts or several different buildings, right? So in that case, when the layout, when the wiring is already concealed, then in that case it will probably be requiring some kind of maintenance in future, right? So in that case, if it requires some maintenance in future, this is the layout which will help the later person who comes in for maintenance to actually identify where the concealed layout or concealed wiring is actually located inside a wall or on the floor or on the ceiling, right? So that is very, very important. So this becomes a very important record that will help people in doing further plans, further extensions of room, or any kind of renovations which are being done in the interior or exterior of the household, right? So this becomes a very, very important layout as well. Okay. So moving forward, along with that, some of the key elements which are there in doing a electrical plan are so and so forth, right? So first thing is, there are certain number of symbols which are to be understood and which are to be used in a complete layout to fill in the details of what actually denotes what. That is something that we will see in subsequent slide. That is something that we will see in subsequent slides, right? So moving forward, we have the symbols, right? So you have the different kinds of symbols which are there. Then we have the wiring. Now in wiring, there are certain times there are different types of systems which are present at the same time, meaning there will be a 16 ampere system which is there, there will be a 16 ampere power supply system which is there, there will be a 6 ampere power supply system which is there, right? So all of these different wirings will require different types of wires and will be denoted with different colors, right? So as we understand that this particular wire is going to carry a higher amperage, and the different color is going to carry a comparatively lower amperage, right? Along with that, several different layouts or several different wires are actually going to reach a dead end. They are not looped into certain cases, right? So for example, a wire which goes from the switchboard going to connect to one particular tube light or one particular bulb, and then it terminates there, right? It doesn't loop over further with that, right? When we are using just one switch to turn on one appliance or one fixture, right? So in that case, this ensures that there are, if in case there are any dead points, meaning that you are leaving a line loose, so this will help you that okay, there is a dead line there, or there is a dead point there, that beyond this the electrical connection is not there, so you need to do something about it, right? Either you need to remove that or reduce a particular switch there, or you can add one more appliance there, or if one more socket point which is there where plug can be utilized, where power can be utilized through a plug, right? Next, the dimensions. Dimensions between each appliance is to be shown, and the height from the floor where it will be kept, right? This needs to follow the standards which are being provided. For example, in case of a air cooler, right, or in case of a water cooler, say for example there is a school complex which is being designed, right? So the water cooler height is something that is always mentioned inside the water cooler manual, right, which is the manufacturer's instruction. So that is to be followed. If it is not followed, then the water cooler may get damaged, and the person who has bought that water cooler will be at a big loss. and then the responsibility of architect comes into picture, right? So we need to be also accountable as architects. We need to be also accountable that we take care of these kind of instructions which are being provided by the manufacturer as well, right? So a platform, probably a platform will be provided for a water cooler which is there inside a school, and then it will be utilized on top of that. Moving forward, so these are the different symbols which are used in creating a electrical layout, right? So looking at the first one, this is a wall mounted light, right? So here it also mentions the elevation, meaning that at what point on a particular wall this fixture will be is to be mentioned in a certain location. Next we have the chandelier light, right? So chandelier light, say for example you have drawn a plan, and then in the middle of that particular room there is a chandelier, so it will be represented somewhat like this. So you have a room, and in the middle of all that you have a big chandelier which is mounted on top, which is hung from the center of the room on a loop or a hook which is there mounted on the ceiling, right? So next we have ceiling mounted bulkhead fitting. So if there is a bulkhead fitting which is there, which has electrical which has lighting layout, lighting fixtures underneath that, so that will be represented as two circles, right? So you will be representing that which is there on top. Then we have ceiling fan. So a ceiling fan is represented in this kind of a format, right? So in certain cases it is also represented in certain offices, sometimes it is represented like this. So there are certain differences, so we are following this one. So ceiling fan is represented like that. Then we have telephone socket. So if there is a landline connection which is being provided, or if there is a internet broadband connection is to be provided, so that will be represented with this kind of a socket, right? And these are all to be mentioned in the plan, right? The elevation, we actually show the elevation of that particular appliance. In case of a TV point is mentioned. So a TV connection, the antenna connection or the cable network connection is presented, is located. So a TV point will be written on top of the plan. Along with that there is a power socket. So there is a combination of 6 to 16 3-pin power socket which is provided. So here is where you can connect your high power consumption appliances which have higher wattage, like your microwave, like your washing machine, so on and so forth. Likewise you also have your 6 ampere power socket. So you have 2-pin or 3-pin socket which is being connected. So this one has hollow, this is not basically filled with any kind of hatch inside, and this has a solid hatch inside, right? So that's the major difference between two. Then we have LED lighting from the ceiling. So on the ceiling, if there is a LED light, if there is a drop down light which is there, right? So you have that particular light being represented by 2 concentric circle and a cross. So that will be on the plan. In the bathroom there may be geyser for hot water supply, so the geyser is represented this way. There is ceiling clamp which is there. So on the ceiling there is a clamp which is provided for us to hang something, maybe some kind of an appliance or a hammock or something like that, right? So that is represented like this. Then you have the bell push button. So you have a push button which is there. So the elevation of that from the bottom, from the finished floor level, is being represented in the plan level as well. So these are all the details which are there in the plan, right? So along with that, on the exterior you will have the calling button, right, or calling bell. So that is to be mentioned in this particular format. Then you have the exhaust fan. So exhaust fan is mentioned this way. There's another way to draw the exhaust fan in a particular layout or a plan layout. So you have a horizontal 8 mark, and then it is within a rectangle. So this will be around your inside your wall, right? So you have the plaster line, this is the plaster line, and then you have your wall here, right? So this is how sometimes represented, along with the direction of where the air will be flowing. So this, if this is exterior, then the air will be flowing this way, right? So this is how the other way of representing an exhaust fan is, or if not, then it will be presented this way. So both are correct, not a problem at all. Along with that, you have the mirror light. So if there is sometimes there are mirror lights which are around the mirror, or maybe there is behind the mirror there is a light, so the mirror itself is illuminated. So this is the way to show that you will write ML behind the mirror line, meaning that it will be lit from behind, right? It will be backlit. Then you have raw power line, raw power line wiring, and raw power layout. So in raw power, you are getting the power connection which is coming from outside before you are distributing that. So that usually is represented with red color. Inside, if you have some kind of inverter which is being used, so the inverter will be placed at a certain place, and then it will be connected to multiple switch boards where you want to use inverter power. So inverter store power. So that kind of power will be that kind of a power wiring or power line will be represented with green color, right? So that is the major difference between raw power line and the inverter power line, right? So sometimes people have their own codes, but this is generally what usually is done, right? Along with that, sometimes there are embedded speakers. For example, there is a large conference room which is being developed, or a large audio visual room which is being developed, so which is being under construction, which is being developed. So around that particular false ceiling, there will be multiple places where you will be placing a speaker. So on top of that plan, you will place the speaker location. So this is how the speaker is represented. Then we come with typical symbols which are there, which are followed everywhere. So the first and foremost, the very important one is the distribution board, from where all these different switchboards are getting connected, right? So you will have switchboard, different types of switchboards which are there, and if you see, the elevation keeps on changing for all three cases. So probably this is at a higher level, so maybe around the bathroom or somewhere else. This is probably in the kitchen, 2 feet 3 inch, right? And the last one, which is about 2 feet, is probably in somewhere around a lower level, so maybe bedside switch or something like that, right? So these are different levels which are to be mentioned, so that it becomes extremely clear where the switchboard pit is to be left or cut out from the wall itself before it is to be plastered, right? Moving on to next one, it is the foot lamp. So if you have a foot switch or a foot lamp around the house, usually this is much common fitting which is used in hotel rooms. So if you go to a hotel or if you go to a resort, usually you will have foot lamp which is right close to the place where you enter the room. It is done, it is going to light the flooring or light a particular part of the flooring, so that you don't meet any accident in, as soon as you enter this new space of a hotel room, right? And then you have a switchboard which is quite high, it shows 9 feet 9 inches. So maybe sometimes you require a AC connection which is there, AC split, maybe you are installing a split AC, so the indoor unit will require a power connection. So that connection maybe is located at 9 feet 9 inches, right? So this is how a complete layout would look like, right? So here is where we start seeing things how they are mentioned. So at each corner where you see lines springing out from, for example, if you see this one, you will see that there are 2 lines coming out of this. If you see this one, there are 2 other lines which are coming out of this. If you see this one, there is 1 line coming out of this. So this is some certain way, this is a certain way in which you actually arrange the switchboards, right? And these are all indicated to be at different heights. For example, if you go to the previous one, switchboard 1 essentially means that it will be at 4 feet 6 inches. Switchboard 2 means 2 feet 3 inches. Switchboard 3 means 1 feet 9 inches. So the height is already decided, and this symbology table or this particular specification table can be provided as a schedule of all the electrical switches and switchboards which are to be provided in that particular drawing. So it will be represented in a certain format, right? So as we mentioned that this is switchboard 3 and switchboard 3. So switchboard 2 and switchboard 2. So this is right next to the bedside, as we discussed earlier, right? And then it is switchboard 1, so it is at the entrance of the bedroom. So this is the way to represent all the wirings which are there, right? So if we look at the living room, so majority of the appliances are being connected to switchboard 2, right, it is right here. So switchboard 2 is has the connection of majority of the items, and then in that case if you see there are two lines which are green colored, this one and this one, which is essentially the inverter line, which also means that the fan and one of the tube lights which are connected to this particular switchboard, or which can be turned on and off from this particular switchboard, will essentially be connected to the inverter, right. So in this particular layout, if we see all the rooms, we will see all the different appliances which are connected by the inverter. For example, if we go to the dining area, none of the appliances are actually connected to the inverter. So if you look at this particular kitchen area, none of the appliances are actually, or none of the fittings are actually connected to the inverter. So we don't see any green lines. If you go to the bedroom, you see one tube light, one fan, and then another light which is inside in the toilet, attached toilet. So that is being connected to the inverter. So you see all green lines. But what's really interesting is you have one switchboard here, switchboard 2, and one switchboard 1 here, wherein you see two lines going, connecting, meeting the fan from both the switchboards. The same is true for the tube light as well, which basically means it is a doubly operated switch or a doubly operated appliance. So you can actually turn this on either from this particular place, or you can turn it on from this particular place, depending on your position in the room itself, right. Likewise, bedroom 2 also has similar kind of connections, wherein at least the fan and the tube light is being operated from two different switchboards and the main switchboard as well, right. So this is the general layout. Then you have the raw power line, which is in red lines, right. So all the red lines you see, they are connecting this way. Inverter power we have already discussed, right. So next is the 6 and 16 ampere plug points are shown in different symbols. So here you have the 16 ampere plug points, right, and here you see the wall hung or wall mounted light, right. So this is how the layout is. So here is where you see the different switchboards which are there. Here is where you see the 6 ampere, and here is where in the kitchen you see the 16 ampere plugs. So there is a variety of all the appliances or all the connections which are being provided for all the different appliances which are there, right. Yeah. So next, now in this particular case you do see that there will be some kind of guidelines which are being used, right. So guidelines do two things for us. For example, if we put the different appliances or different fixtures which we want to use, say for example here we have 3 down lights and 1 chandelier which is being installed in this particular bedroom, and there is also a ceiling fan. So in this case, if you want to determine that this distance between all of these connections is different, or all of these fittings is different, we just have to put the guideline and then measure the distance of the guideline, measure the size of the guideline. If this guideline is equal to this one, then basically they are all equidistant. So here it is, if all of these are at same distances, then all of this is equidistant. Also we get to know that whether the center of that particular appliance is aligned to another center, similar to what we do with the column layout as well, right. Sometimes artistically done, in some cases there are different types of lighting layouts which are being used. Maybe there are not aligned in a straight line, or they are to be laid out in a certain format as per client requirements. So in this case we do see that there is additional chandelier which is being demanded. So there is a chandelier here, there is a chandelier in the bedroom as well, there is a chandelier in the living room as well, in the dining area as well, and then in the entrance sit out area as well there is another one. So client demand which has come in, right. So we have to place it in a certain way. So this is how it will be placed, okay. So it helps us in measuring the area, measuring the distances between all of these different fittings which you have used. And then along with that you can also represent the number and types of switches which are there in particular switchboards. So often the switchboard, this happens in a much advanced stage, but the switchboard schedule, as we saw in the table, the switchboard schedule may also include the number of switches which are there to standardize the switchboard size and switchboard type. So when we say switchboard 1, it can actually be customized and the electrician may come in prepared with all the required number of switchboards which are to be installed in this household. For example, if you say that you will be requiring 5 switchboard 1 type, 3 switchboard 2 types, and switchboard 3 types are required as 4 numbers, right. So, in all these cases, all of this can be prepared offsite in the electrician's office or at the electrician's store, and all of that can be brought together here on the site for the installation and wiring. So, this is how it helps, right. Next, the equidistance measurement can be shown, or it can be measured or written as EQ, right. So, here is where you have the equidistance measurements which are being placed. So, from the wall, this is located, this particular center of this particular fitting, light fitting is located at this distance, then the chandelier is located at this distance, from the chandelier to this particular fitting is this distance, and from this fitting to the end of this sit out is this distance. So, all of it is at equal distance. So, either it can be mentioned as equal with one distance being shown, or it can be calculated on site, and then accordingly it can be done. So, often sometimes what happens is, if in the design process the drawings are not being updated, and then because of unavailability of a certain appliance or a certain fitting, you go to some other brand. So, because the drawing was created considering one single brand or one particular brand, and that brand is not being used, the sizes of the same fitting or the same fixture may change. If the fixture sizes have changed, then the layout will not meet the on-site requirements and the drawing requirements as well. So, in that case, equal actually helps. So, you are basically looking at not the appliance size, but you are placing it at equal distances based on it is not dependent on the make, but you are developing this, you are doing this as per the situation at the construction site, right. And then lastly, all measurements are to be given in the drawing itself, right. So, if you see here, all the distances which are center to center distance from the wall line or the door line till the ceiling fan or the ceiling fan to the chandelier, from the chandelier to the edge of the living room, from that particular point to the edge of the staircase. So, all of these different distances or different measurement dimensions are to be mentioned, so that you actually find the accurate point where that particular appliance or where that particular fitting is to be fitted in that layout, right. So, here is how a electrical plan for a room would look like, right. So, in this particular room, what all do we have? We have one chandelier, we have 2 fans, we have 1, 2, 3, 4 ceiling lights, and then along with that you have 1 tube light here, 2 wall lights here, 1 switch, 2 switch, 3 switch, 3 plugs and sockets, and 1 big switchboard, right. So, this is how it is being laid down, right. So, let us look at what it is describing, how it is describing the thing, right. So, here we have a 16 ampere plug point specifically given for AC. Heights are seen in the elevation of the drawing. So, when we see the elevation of this particular site or this particular drawing, we will see that this particular layout is laid out this way, right. Then we do see the dotted lines. So, the dotted lines are basically nothing but the guidelines to actually lay out all the electrical appliances which are being laid out here. Then we have 2 fans, one of 4 feet and the fans are given, there are 2 4 feet fans which are given for this room. The symbols are drawn as per scale. So, every time you put a fan, if you put it on scale, you will actually see how it interacts with that whole area, right. If it is not to scale, and say for example, this is representing not 4 feet but 2 feet, then it is drawing, this drawing is wrong, right. Then in that case, this drawing is basically completely wrong and it can be used. So, in that case, what is essential is all of this needs to be in scale, so that we can actually know how much area, how much space it is going to cover in a certain condition, right. So, 2 4 feet fans are shown and they are to be drawn on scale, right. So, the overlaps, the places where they are actually conflicting or meeting some other particular point, and it may create an accident. All of that is to be represented correctly, right. So, in this case, the important point which is being mentioned here is it is connected from two different switchboards. So, switchboard 1 or switchboard 2 can operate this particular fan because it is connected by two lines, right. So, this is on one line and this is another line. So, it is connected by two lines and this is going to operate your one single fan which is there. Next, there are lights which are connected to a single switch, right. So, these are two lights which are connected to the single switch, meaning it is connected in series, and once we put on one switch here, this is going to light up both the light fixtures which are here on top of the ceiling, right. And then similar way you will see that there is switchboard 2 which is connected to two other lighting two other lights or lighting fixtures, and then it will be turned on as and when you use the switch there. In all of this, we do see that there is one fan, one tube light which is connected by this switchboard and this switchboard to operate the appliances in case of a light breakdown or in case of a power cut. So, you will be utilizing the inverter because the lines are green, the wiring are green, right. So, that is a layout for a room, the way to do a layout for a room, right. Now, in case of a elevation, when you see the electrical elevations of certain things or certain rooms, what do we see? We do see that okay, there is chandelier to be placed, and then you have the two lighting fixtures which will go on top, right. So, this is how it is placed. Along with that, you need to identify, say if you look at elevation B, this one, we do need to look at the two light fixtures which are there, which are on the wall. Then we need to look at 1, 2, 3, 4, 5 kind of different switchboards which are there. So, 5 switchboards, and for each of the switchboard we do know how distant it is from the ground line, right, from the finished floor level. Along with that, each of the light fixture, how distant it is from the wall or from the door from the ground as well. So, here is where we are placing it from the ground. Here is where we are actually showing it that okay, this is distant from the wall at this distance. In this particular case, a similar kind of line will be drawn like this, or there will be another line which can be drawn like this, that this is at this distance from the place, right. But the height remains the same, 6 feet 5 inches. So, this is how the total layout is, right. So, this is how we read the placing of the appliances which we want to put it, right. So, similarly, in this case we do see that there are two windows and there is a switchboard here, there is a split AC indoor unit here, and there is a chandelier along with two lighting fixtures which are on the ceiling. Then in this case, this particular case, you do have a stabilizer or a inverter layout inverter unit which is here. So, you have a plug point there. Along with that, you have a tube light, you have a fan inside, and then it also shows the distance of the switchboard from the window line, right. So, you have two different switchboards which are here right next to the bed, right. So, this is the complete layout of the bedroom area or this particular room which we were talking about, right. So, you get to know all the different switchboards which are there located in that particular space, and then we get to see all the way in all the different locations where it is located on the wall surface, right. So, that is all about the electrical layout. Now, if we come to the detailed plans of the plumbing layout, the plumbing layout also shows the complete schematic representation plumbing systems which are there in a house, right. So, we do see the placement of pipes, the placement of fixtures, the placement of different appliances, the inlet outlet pipe of the water which will be there, and if there are any hot water pipes or any other utility pipes which are to be presented, they are also being represented. Plumbing plans are also used similar to the way the electrical layout plans are used. Plumbing layouts are used for construction and renovation. So, in several cases, sometimes say for example, a house is being sold to someone else, and the earlier user of the house or the earlier owner of the house had certain different requirements in the bathroom. So, his bathroom was quite conventional, but later the next owner who buys that house maybe he wants to add a bathtub, maybe he wants to add a shower terminal, maybe he wants to add a shower cubicle. So all of these different requirements come into picture, and that calls for renovation and certain degree of construction which is to be done in those locations where there are some plumbing layouts, right. So in that case, what is happening in that case, plumbing layouts actually help you understand that what is the drinking water supply, and it should be safeguarded in a certain way. There shouldn't be any backflow in case of renovation. There shouldn't be any cross contamination of the different pipes which are there, right. So when you are doing renovation of after buying a new house, or buying a second hand house, or buying a used house basically, which is already being used by some other user prior. So in certain cases you will be doing this kind of a test and doing this kind of a renovation, right. So that is where your plumbing plans help a lot. Then the efficiency. So plumbing system will ensure the efficient water supply and wastewater removal, right. So the removal of wastewater is quite important. If it is stagnating inside a house, then it will create a lot of problems. So that efficiency is ensured by the plumbing layout itself. Then you have compliance. For example, in case of a building, you need to comply with the local guidelines and standards. For example, if a certain location does not have municipal wastewater collection supply or municipal sewer line, then in that case all of the waste will go to the septic tank, and only the excess drain or the wastewater drain which is coming from the septic tank will be connected to the sewer. But if it is not present, then it will have to be provided with a soak away pit. So all of these standard guidelines are to be followed in different locations. So the compliance is one additional thing which we didn't much talk about earlier, but in particular case of plumbing, it is present almost everywhere, right. So this is a very important thing. Next is the construction guideline, right. So in case of your complete layout of a building, once you are done with the complete building, just before you plaster, you have to start with plumbing, particularly in case of creating concealed pipelines or concealed fixtures, say a water cistern which is a concealed cistern for flushing water for a WC. So in that case, you need to identify the location of this cistern, you need to place that cistern in a certain way, you also need to draw the location of this, and all of this needs to be completed before you reach the stage where your brickwork is complete and then you are about to plaster it, because that is the point you can put in the cistern. It is extremely difficult and expensive to actually deconstruct a particular constructed building after it is plastered, and then you go for concealed plumbing, because that will cost you a lot. So in that case, a complete plumbing layout helps a lot, right. So moving forward, so in a plumbing plan, the key elements are, there are symbols similar to the electrical layout that we discussed. There are specific plumbing plans, plumbing symbols which are being used to denote the water inlet, the points at which the water will be taken out, or water will be drained. The drains are also mentioned, the traps are also mentioned, the water egress or outlet is also mentioned. So all of these different layouts, all of these different symbols are present, and we need to know them. Moving on to next one is the pipelines. So there are various different pipelines which are there inside a house, or inside, even in case of, say for example, we are doing a hospital. So there are all different kinds of supplies which are there, and they should not cross contaminate any kind of system. There are nitrogen lines, there are water lines, there are oxygen lines which are there, which provide fresh oxygen to the patients. There are water lines, there are wastewater lines, there are again AC drain lines, right. So or AC condensate draining lines. So all of these different kinds of lines should not cross mingle or cross contaminate any of the other line. So in that particular case, all of these is to be understood. So in this case, apart from the different lines which are there, all these essential things are to be understood: the inlet pipelines, the soil pipelines, the hot water pipes, the contaminated water pipes. If there are other air supply pipes, or there are condensation extract lines or extract pipes, So all of this is to be taken care of. Next, same as the previous one, we also need to be very cautious with the dimensions here, and for each of the appliance and each of the fitting which is being shown, which is being implemented or which is being proposed in a layout, all of those need to be shown with their height in the elevation and with the location where it is located in the plan on the floor layout, right. So this has to be followed as per the standard. For example, as same as the electrical layout, in case of a plumbing layout, we also have vendors, we also have manufacturers who manufacture different types of bathroom fittings, different types of plumbing fittings. So all of those standards can be followed from the manufacturer guidelines or manufacturer catalog, and then it can be replicated in the drawing as well, right. So these are some of the standard ways to do it, right. Now let's look at the first appliance or first key fixture that we have is the wash basin. So commercially, like any other fitting, the wash basins are also available in various shapes and sizes, and as per our requirement, we do choose the way a particular fixture has to be there, and it is quite an important fixture to be installed inside a house, or in case of any place where you need to wash your hands, wash your face, so on and so forth, right. And this has to follow some ergonomic standards. For example, if you go to the European side of the world, you will probably see that the wash basins are comparatively located at a higher location than the way it is as in India. So the height, the way in which it is to be placed is to be also understood, and that brings in the case of ergonomics, right. So these are ergonomically designed, and often the manufacturer also provides a guideline of where and how it is to be placed but architect's guideline can be taken with the discretion and with the in discussion with the client, that where particular basin or this appliance is required for the client, and then accordingly it can be placed. So for example, here the basic standard is that we should place it between 790 mm to 810 mm. So in that 20 mm play, you can actually place it. So this can go up 20 mm or this can come down 20 mm. So this is the option you have. So that height keeps on changing of that particular sink, right. And then the sink width should be at least 250 mm, right. So it should be at least 25 mm wide or 25 centimeter wide, so that we don't spill water, right. So it is also going to save some water, at the same time it is also going to save waste and drain water effectively, right. So these are some of the essential guidelines to be known for everyone, so that we don't design something that is not efficient, right. Next, we have the water closet. So in case of water closet as well, there are set guidelines and set drawings are also provided. So it must be, the very important thing in this case is it must be fit and designed according to the standard for good usage. So sometimes there are very cheaper versions or very not so known brands available which are available for a cheap version. So maybe that is not exactly a fit of how you have designed it, and then in that case the standards may also be flaunted in that case, which is why a particular manufacturer was maybe able to design that and manufacture that at a cheaper rate, right. So these are some of the things which are to be taken care of. So often what happens is just before we actually go and buy certain appliances, say for example you are doing a commercial office wherein your number of people coming to work will be a lot of people, and you will require large size toilets where you will have 4 or 5 WC units, you will have about 5 to 7 wash basin units, and maybe in the ladies toilet you will have 8 or 10 water closet units, and then on the wash basin side you will have 8 or 10 wash basin, and all of that is to be tested on site, right. So in that case what happens is the architect along with the contractor who will be doing the plumbing of that particular office building, so that contractor brings in some samples, those samples are tested, those samples are actually checked for their heights, for their appearance in a certain location, and what the the contractor does is he actually creates a mock-up of a corner of a particular room, at a corner of a particular room, and then tries to develop this particular mock-up of a toilet. So there you can go and experience how this toilet will actually look or appear in the place where you want it to be implemented, right? However, in case of a water closet, you really need to know or really need to understand that there are certain guidelines which should not be flaunted with. For example, the seat height should be within 390 to 420 mm range, right? Else, if a person is sitting on top of this or getting up from top of this, if it is at different height, he may slip or he or she may slip, and there would be larger issues which will be created, right? This may break, the person may be harmed, or so on and so forth, right? The lens are also in a range, so it is 360 mm to 370 mm. The width is also in a range, so it should be 435 mm to 445 mm. So these are some of the ranges within which it should be taken care of, right? So next you have the water tank width. So water tank width, the range is about till 400 mm. So if it goes beyond 400 mm, it may be using a lot more water, right? The tank height is about 400 mm. So sometimes it is right close to 400 mm so that it flushes the waste effectively. So all of these things are being thought and designed in a certain way by the manufacturer, but the ranges on the standards are already available, right? The tank depth is about 200 mm, right? So 180 to 200 mm is the tank depth, so that is to be taken care of as well, right? Always water remains below the place from where it is flushed. So in this case, if the flush button is here or the flush handle is here, water will probably be at this height only, right? So here in this case it will be somewhere around this height, just till here to here, right? So that's the case inside, right? Moving on further, so you have all different sorts of bathroom fixtures which are here. So you have different types of wash basins. One may be a circular plan, one may be elliptical in plan. There might be a sink which is there inside the kitchen or inside a kitchen of a hotel. So all of these different ways are there. So then you have the Indian water closet. So this is sometimes called Indian, or it is called Anglo-Indian. There are different ways to name this. So this is also one of the ways in which it is designed. There is a European water closet which is this, so which looks like this, which we often use. So this is also sometimes called as the Western toilet or Western water closet. A similar way is this, which is more on the rectangular side or more on the elliptical side. So there are different ways it is in which it is designed. And then in case of an office or in case of a public common area, public building, right, so you will have a common toilet which will be having a urinal as well on the men's side. So these are the different commonly used bathroom fixtures which have a common template which is readily available in most of the architect's office. So if you are working with the office, you will get a template of all the different scales which are already fixed, available in a block format for your CAD drawings. So you can directly use them and create a good design, right? Going forward, so in the plumbing plan, you do have to be careful of several things. So in this case, you have a half-inch thick glass partition which is there, right? So in this case, you are putting in a partition. You enter from here, right? You enter from here. You have a door. You have a glass partition here and here. You have a brick wall going around all sides. Then you have a drain, a sink which is here, right? Along with that, right in front of the door, you have a wash basin with a countertop, right? So you are describing that, and then you have a pillar cock tap which is here, right? Along with that, you have two it's a mixer basically, and then you have hot and cold water coming from that particular place. Along with that, you have a wall mounted EWC. Now what is EWC? EWC is European water closet, right? So this is how it is being named and described, right? So in this particular case also you have a shower which is here, right? So shower also has a mixer attached to it. So you have a hot and cold diverter, or sometimes it is commonly used as mixer. So instead of diverter, we may also call it, this is the technical term, but commonly in the marketplace it is known as mixer, right? So a mixer is being put at that particular place, which will be helping you to control and throttle the flow of water, either hot or cold, right? So that's the complete idea of the water supply of the to the different points from where you will be using water. In case of soil pipes, you will be connecting all the soil drain which comes from different places, like your bathroom drain, right, where you will be using using your shower area. You will have a drain which is connected to the basin. It will be another drain, maybe underneath this you have a trap which is collecting drain, there is another trap which is collecting drain. So all of this goes to the soil water pipe, and then you have a toilet soil water pipe which will be connected to another pipe which is right next to it, right? So that is taking your waste which is flushed through the toilet to the septic tank or wherever it will be treated, right? Next we have water inlet. So water inlet in this case, as we can observe, is concealed, so it is going right inside the wall, but right just on top of that is the tiling, so it is just behind the tiling, right? So it is concealed. So here is where you can see a double line. So here is the pipeline and here is the tiling line, here is the pipeline and here is the tiling line, right? Likewise in all cases, and it is connected to all the different appliances with all the different units from where it will be used. So it is connected to the shower mixer, it is connected to the wash basin, to the water closet, and to the tap next to the water closet, right? So, and that's the inlet, right? Along with that, if you observe correctly, there are distances which are mentioned, from which distance to which how far this particular location is of this, how this particular pipe is located. So it is also mentioned with the distance of that particular toilet which is there, right? In this case, if you see in the elevation, we are providing all the details of all the different connections which will be there, and also the type which is there. So in here you see there is an angle stopcock, right? So an angle stopcock is actually going to take care of the water flow which is there in that particular location, which will probably be connected to the cistern which is going to provide water for flushing, right? So there is a concealed cistern. So here is where you see the concealed cistern. You see a complete shower head which is there on top. You see the glass partition which was there in the elevation as well. You see the hot water diverter or the mixer which is located here. Then you have the spout, right? So for the body shower, so that is connected with a hose pipe. Next you have the wash basin right in the center on the countertop. So all the details are available same as the way we have done or we have seen in case of the plan. All right, so that was about the module today, and moving on to the next module, we will be coming back to you. Thank you very much.